sometimes you actually don't need a z-table. So you may have encountered the z-table in your statistics classes, but let me tell you this, you actually don't need it. I mean, well, specifically, if you know calculus, or you have a scientific calculator that has calculus functions in it, like calculus features such as the integral, the derivative, or the series, then you don't need a z-table, because I'm going to show you one trick, and that's one trick only. All you need to do is to know this formula. One half plus 1 all over the square root of 2 pi multiplied by the Taylor series expansion from 0 all the way to infinity. Actually, let's go ahead and flip the paper, flip our platform. So all you need is this one elegant formula. So we have 1 half plus 1 all over square root of 2 pi multiplied by the Taylor series expansion so we have negative 1 raised to the power of n, and then times our z score all raised to the power of 2n plus 1 all over n factorial times 2 raised to the power of n times 2n plus 1. Okay, so this is the formula that we need. And don't worry about the infinite sign, because I can go ahead and erase this infinity and replace it with a finite number that is manageable. So you can go ahead and pick a number that you want, but the most accurate one is going to be 10. Yeah, 10. So now this is our final formula to get the area of a z-score in the normal distribution curve, or we call the bell curve. And this formula alone is the reason why z-table has been created in the first place. Basically, early mathematicians in the 1700s used Taylor series expansions in order to identify the area underneath the curve of a specific z-score. But in your statistics class, you may wonder, how am I going to use this in order to get the area between two z-scores? Well, that's actually pretty easy, because the area between them is just a subtraction between z sub 2 and z sub 1. This is the formula that you need to identify the area between two z-scores. And don't be afraid of the symbols that you're seeing, and this may be shocking to you, but it's actually really easy, because this is just straight substitution. So let's have an example right here. For example, I want to get the area between negative 1 and positive 1. So we need to get the area between negative 1 and positive 1. And we can go ahead and use this formula right here to solve for this. So how do we exactly use the formula? Well, that's actually pretty simple. Because all you need to do is to replace z with the number that you first need. So we have negative 1. So we have 1 half plus 1 all over square root of 2 pi. Remember, all you need is to just replace All you need is to just replace. And I'm pretty sure calculators are allowed in the statistics class. They can't just not allow that. So we have negative 1 raised to the power of n. And then remember, it's no longer z. It's no longer a function of z, but a function of negative 1. So we can go ahead and replace z with negative 1. Ignore my chicken. He always does that because he's being an asshole. But let's continue on. So you have negative 1 raised to the power of 2n plus 1. And then all over n factorial times 2 raised to the power of n times 2n plus 1. I don't know why Michael does that every time that I talk, but it doesn't matter. So, moving on, we have this. We're gonna do the same thing for positive 1. So as you can see, the formula actually works, and it's surprisingly more accurate than the z-table itself. So if you don't know, if you don't have a z-table in your statistics class, you can go ahead and use this formula in order to make your work much easier. And trust me, this is much more accurate than the z-table itself.